All right, guys, welcome back to this channel. And in this video, we're going to be doing a particular proof concerning the beta function. So we want to prove the polar form of a beta function. If you're new to this channel, this is BAMS Tutor Academy. Don't forget to like, share, and most importantly, please subscribe to this channel so you can be aware when videos of this nature comes out. Okay, and also tell somebody about it. So we want to show basically that the integral from 0 to 1 of x raised to power m minus 1 minus x power of n minus 1, we want to write it in polar form. So what we want to do is we want to make some representation. So we say let x be equals to the sine of square theta. Now once we can do this, then we want to change the whole expression. So s is sine square theta. So if x is sine square theta, it means that this ds here, this particular ds here needs to be changed in form of r theta. Is that right? So I will just say that the x now will be what? 2 sine x cos s. We know how we did that. Remember from our elementary that if I want to differentiate x raised to power n, right? If I want to differentiate x raised to power n, I'll bring down the n, that's n. I'll write x, remove 1 from the power, and also differentiate that x. That's exactly what I did. So I brought down these two here. That's why I had 2 here. And I wrote back the x, which is our sine now. This is our sine x, sine theta, I mean, sine theta. And I differentiated our x, which is our sine theta, and it becomes cos theta. Do we grab that now? So that's exactly how I got my answer. So let's proceed. So this is actually cos this is theta. So I've gotten what my dx should be. Okay, so now remember from our trig identity that cos square theta plus sine square theta basically is equals to 1. Is that okay? So it means that cos square theta is what? 1 minus what? Sine square theta. Is that fine? And we already said that x is what? Sine square theta. So in the case of 1 minus, so cos square theta also can also take the place of what? 1 minus x. Do we get the idea now? So we want to also deal with the boundaries. So when now in this integral here, this x you can see here is talking about for x. This one you can see for x, and this 0 is for what? For x. But we want to now say what will it be in terms of theta. So we will now say when x is actually 1, what is theta? Because we have to write our boundaries also in terms of theta. So when x is 1 as a boundary, we know that x is 1 and we have squared theta. Is that okay? So from this if I square both, if I find the square root of both sides, I will see what sine theta is equals to 1. So my theta when at the boundary x is 1 is the arc sine of what? Of 1, which in radian will be what? Pi over 2. Do we get that now? So when x is 0, I will do that one to other side. So when x is equals to 0, so I will have something like 0 is equals to sine square theta. Of course, square root both sides, that's 0. So sine theta is equals to 0. So my theta is arc sine of what? Arc sine of 0. So I'll just say that theta still remains what? 0. So I've sorted out everything I want to do. So what I just need to do next is to put in my values. Okay, so what I will do now, let's just clear this part of the board. So we'll rewrite everything from all we've gotten down. Is that okay? So now if I'm writing my integral will now be integral when x is 0, theta still remains 0, right? When x is 1, what did we have? Pi over 2. We just solved that. Good. So now x is what? We said x is becoming sine square theta. All right. So raised to power what? Raised to the power of m minus 1. Do you grab? Then what do we call 1 minus this the other time? We called it what? Cos squared theta to the power of what? N minus 1. Our dx is what? 2 sine theta cos what? Cos theta. So let's bring everything together. Let me do rough calculation. So I have sine. Now this power here, this power can multiply this power from the rule of logarithm, index actually indices. So a raised to power m power of n, it's the same thing as writing a raised to power mn. Abi, good. So if we know that, then we can now say that let me just keep this as sine theta. Then that one can multiply, that will have 2m minus what? Minus 2. Do you grab? Then uh let me put my integral here, 0 pi over 2. Then this 2 here, let me just throw it out. So I'll have my 2 outside. So I can focus on having sine theta. Then times, also same thing happened for cos theta into 2n minus 2 times what? Cos of theta. So if I should do my indices, I'll be having something like this. So let's clear this part so we can have space to work on. So I'll be having something like 2 to the integral from 0 to pi over 2. So now this sine theta is like raised to power 1. So it's like saying sine theta to the power of what? 2m minus 2 plus what? Plus 1. Do you grab? Then same thing, we say cos theta into what? 2n minus 2 plus what? Plus 1. So I have what? 2 integral starting from 0 pi over 2. Then if I should do the calculations, I will have sine to the power of 2m minus 1 theta and cos 2n minus 1 theta, then what? The theta. Actually, so our the theta is here, so we'll forget that. So that's exactly how to prove the polar form of a beta function. All right, thank you for watching to this moment, and if you have not subscribed to this channel, kindly do so that we can be encouraged to do more of this video, and I'll see you in the next video. Thanks for watching.